Alright, we'll get into Unit 4. So this chapter will get into dimensioning, of course, your symbols, techniques, practices, how we do dimension, yeah, so good stuff. So when we study how we do dimensioning, we'll get into your screw threads, then a little about your standard fits, and of course we will end it up with the datum, yeah? So the very first one we'll get into is notes, how to write it, drawing notes. I think some of you remember, yeah, from your mechanical engineering drawing, and in that how we write the notes. So you gotta know how to write the note, yeah, because somebody who is reading the print that you draw, they don't want to get into frustration, yeah, and because if you write your note incorrectly, then you have to revise it, you have to adjust it. So that's a pretty costly, okay? So you gotta make it right when you do it for the first time. And of course, you don't want ambiguities. So from drawing notes, what do we get? So we get the standard, yeah, and then we get tolerance. And sometimes, of course, anything that you want, yeah, write about this standard tolerance, anything that you want to note about these things, references, and your parameters, and other special requirements, you will note it down. Okay, the next one is your procedural method for your manufacturing inspection assembly part. Notes, it should be concise and specific. This is very important. And also you have to use appropriate technical language. It has to be complete and accurate, yeah, in every detail. And make sure when you write it, you don't want other people to understand two different ways. So you have to make it with only one, yeah, possible interpretation for your note. So anybody who read it gotta understand what you want to tell them. So here are some examples. Group 1 shows examples of drawing general notes. Okay, so here, Group 1, I have 4 of them listed here. So the first note is telling you, drawn in accordance with ASME Y 14.5 AM 1994. Okay, it means that we're using the standard. Remove all birds and sharp edges. So we don't want the birds and sharp edges, please go ahead and remove them. Yeah, we're telling what to do. All fillets and rounds are 0.06 unless otherwise specified. So you gotta do, this is the value, otherwise specified in the drawing. Okay, follow what's been specified in your drawing. And tolerance dimensions located in true position are basic. Okay, so it's talking about the dimensioning, especially for end tolerance 1. And it's, this note is talking about its location, the true position, yeah? So anyways, generally it looks like this. This is just a review from MVT 101 anyway, yeah? Engineering drawing. So let's go into Group 2. Alright, Group 2, look and feed notes, yeah? So here, we're using symbols now, yes? So break corner all the way. So just telling you your diameter 8.20 times 4, mean like we have like that circle part of them, yeah, M10, and then times 1.25 dash 6G. So anyway, second group is instead of sentences, yeah, instead of just a regular writing in sentences, we're using the symbols, yeah, and telling them what they are. Alright, that's about notes, and now we'll get into symbols. Arrowheads here, yeah. So arrowheads, we use them for terminators, yeah, on the dimension lines. the points of the arrowheads. This one is actually, your review is a leader line. Yeah, dimension line is a different one. So what we're talking about, where we use arrowheads, you can see them in dimension line, you can see them in leader lines. And that arrowhead, yeah, the ratio got to be 3:1, meaning the standardized ratio for all of the arrowheads that we use in the drawing is about 3:1. Its length is 3, and then your hat is 1. Okay. All right. This one just ignore. I don't know what that is from the textbook. Then we continue. So here you can see your ratio is 3:1. Yeah, 3 and then is to 1. The actual physical size is proportional to the width of the line. Yeah, this width right here on which it is applied, right? So again, your head and your length is 3 and head is 1. Yeah. Sometimes we draw that a little bit larger, like when you're dealing with the detail view, yeah, plane, or when you're doing the sectioning, yeah, section cutting plane. At that time, we're gonna draw a little bit bigger than your normal arrowhead. So that's about 0.375, yeah, 3 by 8 inches in length. So what's important about arrowhead is just we want, yeah, we want somebody who's reading your drawing to call for that attention. Yeah, we want them to pay attention. Hey, the dimension from here to here is this. Yeah. Oh, hey, here's a leader line. I want to tell you this. Yeah, dimension about the circle or something. Then we get into the regular dimension on drawings. Yeah, the actual site is not specified in the standards. But we usually go like 0.123 to 0.1875 insides. Yeah, so this little one. Of course, it doesn't really matter because you're not doing hand drawing anyway. You have to draw by hand only here in this class, yeah, for a while. Most of you will be using the application program nowadays. This is a little bit older textbook. But it's good to know, yeah, it's good to know. Even if we use everything like auto program application. So for metric, yeah, drawings 3mm to 4.5mm in length. Of course, your CAD and CA system, we already have a default set to it. Yeah, we have 4 different types, and we follow ASME 14.2M 1992 to ANSI 14.2M 1979. Alright, so let's take a look at this arrowhead. Yeah, this is a following ASME 14.2M 1992. That's just a national standard. So this order preference, you wanna go, yeah, from left to right. Look at this, yeah, look at this arrowhead. Second one, yeah, looks like this, see? Just the feel is different, that's with the black and that's white. The next one we use this, so you prefer to use this, yeah, and then this and then that. So that's what's saying order of preference, go from left to right. Then the last one, yeah, we usually use this. We don't even see this. Maybe some people might use it. So if you see this, don't freak out. Yeah, you know that that's just an arrowhead. Alright, then we get into extension lines. Extension lines, your review is a thin solid line. Solid, okay? We use it, of course. So here is a part, yeah, and is outlined by this visible line because it's all solid anyway. So in order for us to dimension the part, yeah, it is necessary that we use the extension line. So we're going to extend the surfaces beyond the limits, you know, of the geometry that just formally right. Meaning like we're going to do extension line in this object to do dimensioning. Yeah, so we start drawing. So these are your extension lines. Why do we draw extension lines? Because we want to do dimensioning. Showing you again, yeah? These are just a thin solid lines. You know that. I don't have to go over this. And here, look at that. So there's a gap. Yeah, pay attention. I know that some of you like totally like draw it like from this edge all the way continuously. Don't do that. Yeah, leave a little bit of gap, about like 1/16 or 1.15 millimeter. Yeah. It doesn't have to be accurate when you draw by hand. If you make it this, yeah, line by using ruler, if you draw it nice straight, then I'll feel very happy. But I'm not gonna check like from here to here is 1/16 gap, yeah. But of course you can do it like all the way out here. It's gotta be a little bit close and then give a little bit of gap. Yeah, it doesn't have to be that accurate, but then you gotta be accurate, reasonably accurate, yeah, to portray 1.5 millimeter or 1.16. Then I'll be very happy. Okay, so here now we can see, yeah, it's perfect. Gap, 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 extension lines, and then yeah, dimension lines, and we have our arrowheads at the end, yeah, terminated with the arrowhead. Then the next thing you have to pay attention is we have already drawn this extension line and put this dimension line. When you put it, you can put this thing in the middle. You can put that thing over there at the end. You gotta put it at the top, and you gotta leave a little bit of space, just like that. Yeah, about 0.125. Yeah, that's about 3 millimeter. Okay. So when you go back here, this is about 1.5 millimeter. Yeah, so 2 times of that. Okay, about 3. This is 1.5 gap, and we have about 3 millimeter. Yeah, have some length of this extension line above that dimension line. Okay, so make sure pay attention. So of course when I correct, yeah, your answer, I check this and I check that, and this gotta be smaller than this, yeah, from here to there, yeah, this little starting point is at the end of this arrowhead to the end of the extension line, gotta be twice than this little gap, yeah, so at least I check that. Okay, now we're gonna put the value. We put the value right here, yeah, and most of you already know now what to do with the dimensioning. Automatic dimension is just you have a value right in between the dimension line. Yeah, that's because long time ago, yeah, when they did hand drawing, is because of the space limit. Yeah, we put this into the line instead of writing on it. Yeah, to save the space. Our linear dimension placement. So let's take a look at this. The dimension placement is nothing but you can place the dimension on the drawing in many different ways. Yeah. So we will take a look at how we do this placement. So here, arrows in, you have dimension in. Yeah. Look at this. So this is the first example. So you have your dimension, the arrows are inside of the extension line. Yeah, we say in. Whoa, where's the in? I don't know. So the dimension line and the value are inside of the extension line. Okay, so that's your first placement. Second, out. See, the arrow is out, the value is inside of this extension line. The third one, arrows is in, the dimension is out. See, the arrow is inside of this extension line, but the dimension out. So it depends on the space. Yeah, it depends on your drawing space. Alright, then arrows out and dimension out. Yeah, both in, both out, value in, arrow in. Okay, so there are 4 types. Alright, let's take a look at here. This is just showing you again, the same thing. So you have 4 different types. Of course, the value can change. Yeah. Alright, well, that's it for the very first, your symbols and your notes.